Okay, the lesson we're about to do here, if you are in Math 053, is extremely relevant. We're going to look at most scenarios that come up in section 3.7, wide variety of the types of examples they go through and the practice questions at the end. Even though word problems are a big part of Math 038 and Math 052, they are not going to look like the ones that we're doing right now in those courses. In those courses, there's going to be a lot more concrete, like Bob is building a grain silo and wants to know how much grain it can hold, or those types of things, right? Where you're going to be going back to those formulas and plugging in values to work out what you want to work out. Whereas in Math 053, they get a lot more. I don't know what the word is. The word problems are a lot more abstract. They set up these sort of scenarios that don't really seem to relate to the real world, and then ask you to solve the equations. The reason you're doing this is because ultimately, if you go into the sciences, or if you go into even finance, for sure, economics, some accounting, you will end up with situations where you do need to find that, oh, well, this is 3 more than 5 times that. How am I going to figure out what that was? Um, uh, sorry. Okay. So you actually will run into surprisingly similar scenarios in real world situations to these sort of manufactured scenarios you're going to see in these ones right here. So equations resulting from word problems. So here we're just going to try a bunch of them. So Randy bought an electric drill on sale for $60. That is 2/3 of the original price. Question: what was the original price of the drill? And this is, I started by putting what they were similar to examples. I think I forgot to do that as I went on to the rest of them. But this is similar to example 1 in section 3.7 of Math 053. Okay, so you always want to start with these let statements. It seems like a waste of time, but as we just saw actually in our open question time there, it often organizes your thinking and helps you. By the time you get to the end, sometimes you forget where you started and you look back at that original statement. What was P again to begin with? Oh yeah, and then you have to do something else with it or whatever. So let P equal the original price of the drill, because that's what we're looking for. And now we're going to try and turn this sentence here into an equation. So brought an electric drill for $60. Okay, so let's start with that. $60. Which is, well, that's code for an equal sign. So $60 equals what? 2/3 of the original price. How do we say 2/3 of something? We say that with a multiplication. 2/3 times the thing. And the thing in this case is the original price. So if I want to say what's 2/3 of 900, you go 900 times 2/3, or 2/3 times 900. So here we've turned this sentence into an equation. 60 in red is equal sign in blue, 2/3 of the original price, 2/3 times P, like so. And now, once we get an equation, we know we don't need to write that times sign there. Once we get an equation, we simply want to forget all about Rani and her drill that she bought and the sale it was on and how much money she spent, and we simply want to solve that equation. So how do we solve this equation here? We want to get P by itself. P isn't by itself because it's being multiplied by 2/3. We looked at ones like this and saw there's various ways to solve them, but by far the fastest way is to multiply both sides by 3/2. Why? Because we know the 3's cancel and the 2's cancel. Or if you want, 3 times 2 on the top is 6 and 2 times 3 on the bottom is 6, and those cancel, as another way to think about that. The point is we get P all by itself, which is the whole point, right? The fractions cancel out. And then on the left, we just got to work out what is 3/2 times 60. Well, to do fraction work, we make that 60 over 1. And we could multiply the tops and then divide by the bottoms, or we can also do some canceling first, which usually saves you a bit of time. 60 over 2. And remember, we can only do this for multiplication, right? We can't do this little cross-canceling when it's adding, subtracting, or dividing. And you get 3 times 30 is 90. So the original price of the drill was $90, which, by the way, word problems, we generally are looking for a sentence answer at the end as well, at least if you're doing a written test. Again, here you could have gone 3 times 60 is 180 divided by 2, and you still would have got 90. Just the canceling saves you a little bit of an extra step and some bigger numbers. So there's our first example. And what we want to notice is a few things, 3 key things, I'd say. The let statements to organize your thinking, the turning the sentence into an equation, which is the part people find the most difficult. And then once you have an equation, putting all of the word problem stuff, putting all this out of your mind, and simply take that equation and say, okay, how do I solve that equation for the variable p equals 90? All right. Enjolras, a good French name, collects red and black beads. And some of you might catch a little Les Miserables joke going on here. The number of black beads is 5 more than twice the number of red beads. Enjolras has 39 black beads. How many red beads does he have? Okay, so, let statements. Let B be the number of black beads, and we could let R be the number of red beads. Now, you got to be careful here because we don't want an equation that has 2 variables in it, but I think it's going to work out okay in this case, and you'll see why. Let's try and build an equation now. Let's see. This sentence right here is the key. The number of black beads is 5 more than twice the number of red beads. Well, let's try and write that down. The number of black beads, B, is there in red. That's an equal sign. 5 more than, now let's just stop right there. 5 more than something means something plus 5, right? 5 more than something means something plus 5. And then you say, what is that something? Well, we're going to put that another color here. The something is twice the number of red beads, right? So 5 more than means a something plus 5. Then you go back and you read, what is that something here in orange, twice the number of red beads? How do we write twice the number of red beads? 2R. Now I have a problem. I have 2 unknown variables here, the B and the R, but luckily they gave me a little bit more information. Oh yeah, I just took out the coloring, I guess. Here in green, they also told me that Enjolras has 39 black beads. So that B can become a 39. Now there's other ways you could have done this. You could have let R be the number of red beads, which is what you're trying to find. And then you could have said that 2R plus 5 is the number of black beads and built your equation from there. It would have been the same. I think this is probably a bit easier, but either way, the point is that we now have an equation that has where we know everything except for the one variable that we're trying to find. So it's just a regular old 2-step equation. I start by taking that 5 that's being added on the right and change it to 5 that's being subtracted on the left. 39 minus 5 is 34. And now to get the R by itself, I divide both sides by 2, like so. The 2's cancel, leaving just an R on the right-hand side. 34 divided by 2 is 17. And then I think we probably want a sentence answer here. Enjolras has 17 red beads. Okay, so again, the let statements to organize your thinking. Turn the sentence into an equation by working through from start to finish, left to right. plug in anything else that you know, which in this case there was this extra little piece of information that the black beads is 39, and then simply solve the equation. Sum of 3 times a number and 16 is 43. The sum of, okay, so let's let n be the number that we're trying to find. There's organizing our thinking. Now let's read this sentence. The sum of, stop right there. What does the sum of mean? That means some things are going to be added, right? So there's a plus sign because it's telling us that there are some things that are going to be added together. What are the things that are added together? The first one is 3 times a number, 3n. And the second thing that's being added together is 16. So again, you see how I break this down little by little. What happens a lot of times is people just stare at these word problems and they say they don't know where to start. They just doesn't make any sense, right? And so you don't necessarily start at the left hand to just write it all out. It just doesn't magically come to your brain, right? You need to break it down. The sum of, okay, 2 things are being added. What are the things? 3 times a number and 16. 3 times a number, 3n, and 16. Okay, let's carry on in the sentence. What's next? Is. Okay, we know what that means. Orange equal sign. And what is it equal to? In green, 43 goes on the right. So there is our equation that we have built from the word problem. Now let's forget all about numbers and word problems and everything else and simply take that equation that we want and solve it. And so I don't actually work this one out here. If you want to try it on your own later, jot it down. 3n plus 16 equals 43. And you should get an answer of n equals 9. The number is 9. Okay, on to this one. The sum of 2 numbers is negative 17. How can 2 things add up to be a negative? Well, probably at least one of them is already negative, right? If they add up to a negative number. And so that's okay. One number is 5 less than the other number. What are the numbers? Okay, we're looking for 2 numbers here. And you often hear one to say let n be equal to either the smaller number or the larger number. I'm going to say the larger number here because it says one number is 5 less than the other number. So clearly one is smaller than the other. I'm going to let n be the larger number. And what that means is that the other number is n minus 5 because it's 5 smaller. You could have totally reversed this and let n be the smaller number, then n plus 5 is the larger number. You will get the same answer. Your n will be different, but that's okay because we're going to solve for n as the larger number, right? Because that's what we said n is. If you did it the other way, you would solve for n as the smaller number. You're going to get the same answer of the 2 numbers regardless. Okay, so let's build an equation. We know that the numbers are n and 5 less than n because it tells us so. The sum of 2, okay, the sum of, that means 2 things are going to be added. What are the things that are added? 2 numbers. What are the 2 numbers? All right, put them both in blue now. The 2 numbers are n and n minus 5. Because that's what we set them up to be. Is, that means an equal sign. Negative 17 in green, like so. And there is our equation. The first number n, the second number n minus 5, added together is equal to negative 17. Okay, erase all the colors. We're going to solve this equation now. On the left, I see some combining n plus n, which I remind myself actually means 1n plus 1n. So 2n. And now I have a regular old two-step equation. The minus 5, the subtracted 5 on the left becomes an added 5 on the right. Careful with this addition. This is 17 to the left and 5 to the right, so going in opposite directions. So subtract those numbers. 17 minus 5 is 12. I went further left, so it is going to be negative 12. So 2n is equal to negative 12. Divide both sides by 2 to get n by itself. 2's cancel, of course, which is why we did it. Negative 12 divided by positive 2 is negative 6. Okay, now careful, you can't stop there because we're not done. We found the larger number. N is the larger number, right? Negative 6. Don't get bothered by the fact that the larger number is negative. That just means the smaller number is going to be even more negative. Let's go back and find the other number. The larger number is negative 6. N minus 5 is the smaller number, so negative 6 minus 5, which is negative 11. So the numbers are negative 6 and negative 11. By the way, you can check this out. The sum of two numbers is negative 17. So if we add these two numbers together, negative 6 and negative 11, oh yeah, negative 17. And one number is 5 less than the other. Yes, negative 11 is 5 less than negative 6, right? So these two numbers meet the criteria. So you see how organizing our thoughts helps here, because otherwise, even if you set up the equation right, you get to the end and you have n, and you don't know, oh, do I need to add 5 or subtract 5 to get the other number? Well, you look back to how you set it up. N is the larger number. Oh, okay, I need to subtract 5 to get the other number. This lesson is a little bit longer than most, by the way, so I don't want to race through, but I also don't want it to go too long. One number is 13 more than 4 times another. Their sum is 3. So once again, we got two numbers, the good old two-number questions. So let n be, let's say that sometimes I say the smaller number, or if I'm not sure which one's going to be smaller or bigger, sometimes I just say let n be the first number and then figure out what the other number is. So if n is the smaller number, then the larger number is 13 more than, so plus 13, 4 times the other number, 4n. So n is the first number, the other number is 4n plus 13. 13 more than 4 times the smaller number. Now I'm going to take this equation, their sum, so that's a plus sign, is, their sum. What's being added? Their sum. Well, that's the two numbers, right? N and 4n plus 13. I don't know if I wanted that all to be purple. I hope that makes sense. N is the first number being added to 4n plus 13, the other number. So the sum of the two numbers is, so an equal sign, 3 on the right-hand side. So there we have the first number n and the second number 4n plus 13 added together makes 3. Now we are going to, so this one I'm going to leave for you to try as well on your own. So there's the equation. You're going to collect the n plus 4n to become 5n, and then you're going to have a nice little two-step equation, so you can try this on your own. You should get answers of negative 2 and positive 5. Or, of course, if you're watching the video of this later, pause it right now. Try to finish that off and see if you can match those answers. If anyone wants, during open question time, during class here today, I'm happy to finish this question off if you're uncertain about how to get to the end of this one. Okay, the good old consecutive integers questions. You will definitely see some of these in Math 053. The sum of 3 consecutive integers is 39. What are the integers? So we got 3 numbers this time, not just 2. So let's just start the way we always start. Let n be the first integer. And remember, integers are just the whole numbers, positive, negative, and 0 all together. Let n be the first integer. Consecutive. What does consecutive mean? Consecutive means one after the other. So if n is the first integer, the next one is one more than that, n plus 1, and the third one is one more than that, which is n plus 2, which great, as somebody in the class just very astutely figured out. So now what are we going to do with those three integers? We are going to sum. We are going to add them together. All three of them, so two plus signs, n, the first integer, plus n plus 1, the second integer, and n plus 2, the third integer. We're going to add them all together, is 39 in purple, like so. And now I'm going to erase all the colors, and we are going to solve this equation. I'm going to do some collecting. I see n plus n plus n, so I'm going to make that 3n. And 1 plus 2, I'm going to make 3. And then the equals 39 on the right-hand side. And from here on in, it should just be standard equation solving, so I'm going to go through a little faster. The plus 3 on the left becomes a minus 3 on the right. So we get 3n equals 36. We get n by itself by dividing both sides by 3, because that makes the n by itself. 36 divided by 3 is 12. Okay, let's go back. We got n. We've solved the equation. Now we got to go back to the word problem. What was n? N is the first integer, 12. The second integer is n plus 1, 13, and the third integer is n plus 2, 14. Or once you know the first one, you know the other two are the two that come after it, right? So 12, 13, and 14. And you can double check, add up 12 plus 13 plus 14, three consecutive integers, that add up to 39. Yes, it works. The sum of three consecutive odd integers is negative 21. Okay, three consecutive odd integers. Well, okay, let n be the first one, but if we have odd integers, how far apart are odd integers? Consecutive integers are 1 apart. Odd numbers, 3, 5, 7, 9, 11, 13, they're all 2 apart. So that means the other two are, instead of being n plus 1 and n plus 2, are actually going to be n plus 2 and n plus 4. And the same if it was three consecutive even integers, by the way, you would have the same setup. So there we have three consecutive odd integers. The first one, 2 more than that, and 2 more than that. And let's build the equation. We're going to add all three of them again like we did last time. So the first one n, the second one n plus 2, the third one n plus 4. Bada bing, just like that. We are adding together three consecutive odd integers. That sum is in yellow, so equal sign, negative 21 in purple. That goes on the right-hand side. And there we have built the equation. The sum of three consecutive odd integers, n and n plus 2 and n plus 4, is equal to negative 21. Now let's erase all those colors, or just, I'm rewriting it. Oh yeah, so this is another one I'm going to let you to try later on if you want to. I'll give you a sec if you want to write it down, or again, if you're watching the recording later, pause it and give it a try. Solve that equation and you should get negative, I think you should get negative 9 actually as your answer. And then that's the first odd integer. 2 more than that is negative 7, the second odd integer. 2 more than that is negative 5, the third odd integer. If you want to try that on your own, you can. Again, I'm not necessarily going to do all the equation solving because we've done all the equation solving. The new stuff here is creating the equation from the word problem. And oh, that's my last slide. Okay, so there we go, a smattering of word problems. Like I said, that covers most of the main scenarios that you will see in section, I want to say 3.7, it's either 3.7 or 3.6 in Math 053.